Hi everyone and welcome to this video. In this video I'm just going to extend a little bit on the solving polynomial equations that we did in class recently, and what I'm going to do is I'm going to have a look at something called the conjugate root theorem. So that is that if some polynomial p of z has all real coefficients and p of alpha is equal to 0, and that's where alpha is some kind of complex number, then p of the complex conjugate of alpha is also equal to 0. Basically what that means is that factors and solutions come in complex conjugate pairs. So there is a fairly nice proof for this, which we'll go over in class. I won't actually do that in this video, but let's just have a quick look at how it works. What I'll say about it is it's a fairly nice one to know about because it can save you a lot of trouble in looking for different factors and that sort of thing. So we're going to show that z plus 1 minus 3i is a factor of that polynomial, and hence find all the solutions to p of z equals 0. Now, to show that that's a factor, we're going to be using the factor theorem that we went over recently. And so what I really need to show is that p of negative 1 plus 3i is equal to 0, because that will show that it's a factor. So p of negative 1 plus 3i is going to be equal to negative 1 plus 3i cubed plus 4 times negative 1 plus 3i squared plus 14 times negative 1 plus 3i plus 20. If I expand that out, I should get negative 1 plus 9i, that's going to be a plus 27 and a minus 27i. That's the first brackets there expanded out. Then going to have a plus 4, a minus 24i, and a minus 36. So that's the second bracket there expanded out. Then we've still got a minus 14, we've got a plus 42i, and we've also got a plus 20 on the end there. So that's quite a long one. And I'm just going to try to simplify it down. If I look at the real parts, I've got negative 1 plus 27, so that's 26. Plus another 4 makes 30. Then minus 36, which is going to be negative 6. Take away 14 will be negative 20. And then adding 20 makes 0 for the real part. And the imaginary part, I've got 9i, take away 27i, so that's negative 18i. Take away 24i makes negative 42i. And then I've got a plus 42i, which makes 0. So it is indeed equal to 0. And so therefore, I can say that z plus 1 minus 3i is a factor of p of z. So the really nice thing here is that this polynomial has all real coefficients, and so what that means is that the conjugate of this is also going to be a factor. So using conjugate root theorem, z plus 1 plus 3i is a factor of p of z. I'll just say by conjugate root theorem. And so then I just need to find out what my other factor is, because it's a cubic polynomial. So what I'm going to do is I'm actually just going to multiply those two factors, and I'll see what I end up with. So z plus 1 minus 3i and z plus 1 plus 3i. And this is really a difference of two squares, because we've got z plus 1 and then plus or minus something. So that's going to become z plus 1 squared minus 9i squared. So that becomes z squared plus 2z plus 1, and then that's going to just become plus 9. So that is z squared plus 2z plus 10. So that's the quadratic factor. Now what I know is that p of z is going to be some kind of linear factor multiplied by that quadratic factor. So the thing is, I need to make a z cubed term. So to get a z cubed, I can just put a z here, because z times z squared is going to give z cubed. But that's also going to give me a plus 2z squared term. So the thing is, I've got 2z squared, I need to have 4z squared. So I need to get another 2z squared somehow, and so I'm going to get that by putting a plus 2 here. Because that is going to multiply there and give another plus 2z, which gives the plus 4z squared that we needed in total. Okay, and so I've got all three factors now. So I can say that p of z is equal to z plus 2 multiplied by z plus 1, take 3i, multiplied by z plus 1 plus 3i. And so solving where p of z is equal to 0, is going to, sorry, what am I doing? Don't worry about that. Is going to give z equals -2 and z equals -1 plus or minus 3i. And so there we have our three solutions. Anyway, I'll leave that video there and see you next time.